Okay, and fantastic. So welcome everyone. We've gone through our social time. So for the people on the recording, we just kind of had a good time now chatting with each other. We're going to get into our main presentation, a healthy job market. We've shared a bunch of jobs, so that's good. And so for tonight's main presentation, and also let me remember, we have two $50 gift cards, AWS gift certificates, AWS credits to give away. We'll do towards the end. So remind me if I don't remember to do that. And there will not be science fiction questions because Brian's not here and that's not my forte. I can spin a random number generator though, like nobody's business. So great. So so today we're really fortunate to have Paweł Piwosz, who's actually calling in from Poland. So thank you for staying up so late. He's got like 20 years of experience in IT. He's at EPAM now, as we were just talking about, who has lots of jobs around the world. He's a lead systems engineer, training at Cloud Academy. So all sorts of good chops that way in terms of also a DevOps expert and sort of enthusiast, I would say, or Agile and DevOps evangelist. So really happy to have you with us tonight and share some of your knowledge and really an interesting talk to see about using Lambda in sort of an AWS only stack, which is, I think, really interesting because, you know, very often we use all the latest tools and building up these frameworks, but sometimes you kind of need to peel some of that stuff away and you just need to have something that's a little bit more, you know, in the house and keep it simple and fewer dependencies. So I'm really excited to hear about this. So with that, Paweł, maybe you could introduce yourself a little bit and take it away. You can share screen at will. And the only other thing I'll have to say is, I think it's good if we can have people ask questions interactively. But if that's not your style, then feel free to ask people to defer, and we'll certainly have some Q&A.
It works perfectly well for me. So if you have questions, you can interrupt me and shout. All right, let me share my screen. The most popular quote from last year, right? All right, so yeah, as you mentioned, we will talk today about CodePipeline and how to deploy Lambdas with CodePipeline and AWS stack only. As an intro to this talk, I can say that I really hated CodePipeline before, and in one moment I decided to play with that long that I will like it or just throw whole AWS away from my career path and switch to something else. And fortunately for me, maybe I stayed with AWS because I started to like CodePipeline for multiple reasons. So let me start a little bit about myself then. So as you already know, my name is Paweł Piwosz. I'm located in Poland, in Kraków. Don't visit Kraków in the winter because of air pollution. So please do not do it. And I'm working at EPAM right now as lead system engineer. We are adding always in DevOps because we are treating DevOps more like a culture, like a mindset than just a tool set. I am DevOps Institute ambassador, and recently I become AWS community builder, which made me very happy. So yeah, that's about me. My main responsibility right now at EPAM is to teach, influence, maybe somehow, I don't like this word anyway, young people to become cloud engineers, DevOps in mind. So we have like 50 people in the program, so hopefully most of them will stay with us as a proper engineers.
So they're mainly in Poland? Where are these?
Yeah, yes. And this program right now is in Poland. EPAM has multiple programs around. So the most popular are in Ukraine, Belarus, I think in Russia. Probably we will extend it at least to West Europe, but we will see what future brings. Right now, my responsibility is in Poland only. So that's what it is. So what you said was very, very interesting. We are very often using different tools in order to achieve CI/CDs, our goals, to deploy stuff where we want to be deployed, right? And the most popular, I don't know what is your reality, but here in Europe is Jenkins. So Jenkins, then nothing, and maybe like a Travis, maybe Circle CI, etc., etc. Azure DevOps is very popular these days, but if you talk about CI/CD, in mind you almost always have Jenkins, at least in our reality here. So to demystify it a little bit, Jenkins is not CI/CD, right? Jenkins is the only tool for it, nothing else. One of the tools, not the best, not the worst, let's say, but only one of the tools. So first, what I want to do really, even if this will be like a basics for you, but I like really to have like a common understanding what is CI/CD really, because I'm doing a lot of technical interviews, even on higher levels of engineers. And I see that understanding what is CI/CD is difficult for people. They have problems with that. They have problems with almost all elements of this CI/CD really. So I'd like to have like a common ground here for us to understand what I'm talking about, right? So we have CI, right? We have CD, we have another CD, and this creates some problems for people to understand what it means really. So shortly, what elements we have here? We have continuous integration, right? We have continuous delivery and or continuous deployment. That's the three elements here, only three elements. Now, continuous integration is a kind of regular commits, unit tests, artifact build, and storing this artifact somewhere. Here, continuous integration ends. We are starting with the code, we are finishing with the artifact, this artifact is stored somewhere, done, right? And from this moment, continuous delivery or continuous deployment starts really. So we have like automated tests on different environments where this artifact is shipped. We have automated delivery of these artifacts. We control what is delivered, and we have something what I'm calling one-click deployment. We stop somewhere before production to do, let's call it manual intervention. I don't care if this will be kind of check, some highest manager need to say, okay, go on, whatever, there is a stop and manual intervention is needed. Continuous deployment is very similar, except one element which changed everything really. So this is automated installation of these artifacts on production, right? And I'm calling this zero-click deployment. There is no intervention from the human being. It's automated process from the commit to the production. Small change, but it changed really everything. That's why what I will show you today is continuous delivery, not continuous deployment, because I have only 1 hour, not 3 hours. This is the difference here, the main difference. So as to give you maybe better visualization of the process, we have commit, right? For the CI, we have commit. Then we have static code analysis, like for example, SonarQube, etc., etc. It can be executed with the commit. It can be executed with pull request. It can be executed later during the test phases as well. But let's say it is here. After that, we have kind of unit tests, which can be combined together. We are building the artifact. We test this artifact if this artifact is shippable, because this is kind of important thing.
Is your background of your PowerPoint all greenish, or I'm just trying to wonder if it's my mic monitor which is an issue? Is it like greenish? So this, sorry.
I'm laughing because I'm kind of colorblind, so don't ask me about that.
All right,
Yes,
sorry.
yes, it's green.
Okay, sorry. I
All
just
right, all right,
to
move
make
on.
sure it's my
No. It's kind of greenish, I think. So
Okay, sorry.
I hope
Sorry,
at least.
I didn't mean to change the
No.
chain of thought. Please continue.
No, no worries. I'm laughing because I love to laugh about that. So we are testing this artifact. So we can imagine, for example, we are building the container, right? We should test if this container is able to be executed somehow. And then we store artifact somewhere. It can be Artifactory, it can be AWS code artifact, etc., but we are storing it somewhere. And from this moment, CD starts, right? So if we are talking about continuous delivery, we collect this artifact, we are deploying it, for example, on QA, then we are testing it, of course, automatically. We deploy to release candidate, we again test it, then we have the manual approval and production. If we remove this step, we are start talking about continuous deployment. Right? This is what I wanted to just set. But this is not all. Here we are talking about pipeline, not CI/CD as a construct, really, because this is a little bit bigger. So when I used to work with my previous customers, I developed some way of designing CI/CD approach for the whole organization or whole project in relation to, well, customer needs, really. So we took into consideration multiple elements. For example, constraints which we have in relation to our pipelines. What kind of constraint here? For example, you have the financial company who is using AWS, right? They have this boundary. We are using AWS. And in this case, you can say, all right, so we need to use all AWS tools or install our platform inside AWS, because we cannot use, for example, CI, which is a cloud-based solution, right? This is our constraint here. We need to think about branching strategy, because still, even if I like right now CodePipeline, it's not the best tool for Git flow approach, for example, right? We need to think about SDLC. We need to think about responsibilities here. For maybe very simple idea here. Who is responsible to click this button with continuous delivery? We need to think about deployment strategies. Do we think about rolling updates? Do we think about blue-green deployments? Do we think about canary deployments? This is also important, very important in the chain, how we design our actions, right? We need to think how we version artifact, not storing, but version artifact, because this may bring some issues. I face that. So that's why I know what to ask here. We need to think about releases, right? So if we pack bunch of updates in one pack and deliver this pack as single element, or we are continuously deliver changes to environments, and which environments really. We need to think about tools we will use. This is also related to branching strategy, deployment strategy, constraints, etc., right? We need to think how we will rollbacks. We will do rollbacks, or do we have any other approach if something is going wrong with our deployment of the production? Right? We need to think if we are doing our CI/CD using infrastructure as code or not. We need to think what kind of quality gates we will have during the process, right? There will be different quality gates if we are doing continuous delivery and continuous deployment. And finally, how we will monitor our CI/CD, right? And here I'm not saying that if pipeline is working, Jenkins is working, but how we measure success, let's say, of our CI/CD, right? So as you can see, there is a lot of things to think about. So now I'm going to what we will do. So we will do something very simple in this presentation here, but as Well, I am DevOps with a lot of years of experience, so I can do it. I can do simple things in a very complicated way. So we will build this, right? Very simple thing. We will have API gateway. We will have one small Lambda function, very small Lambda function, and that's it, right? And we will create the whole pipeline, CI/CD pipeline, using AWS CloudPipeline for it. Code is at this moment in code commit, so I will not create code commit with CloudFormation, but it is possible, obviously. Deployments will be using CloudFormation, and also pipeline will be built through CloudFormation, right? So we can automate everything really here by infrastructure as code from the beginning to the end, really. I think I don't need to explain you really what is
Hey, Pavel.
AWS Lambda.
So just to be clear, you said you're doing a simple thing in a complicated way.
Yeah.
But you're not saying you're building a Rube Goldberg machine just to make it complicated. It's that you're recommending a potential path through the whole CI/CD pipeline,
Yes.
that when the application gets more sophisticated, you would still be happy to use this capability. Now, it's
Yes.
complicated, but just because you need all these parts to look for your previous
yes, exactly,
slide.
exactly. And this is exactly what you said, and this is also a scalable solution. So in time when new functionalities, new things comes into the landscape, you can add it easily to the process here, right? So so this is also let's say designed boldly to have this possibility in mind, right?
Right. So I might say, so you're building a simple thing in a complicated way, but complicated / robust and scalable.
Yes, to make this simple.
Yep,
exactly.
Yep. Okay, good. Just want to make sure that was
exactly.
clear.
Yeah, exactly. So I'm not using things which I don't need here, really, because I really love simplicity. And that is something that I always try to remind to everyone. If you can build something in simple way, do it. Because you have less elements to fail there. So what is AWS Lambda? I don't need to tell you, right? This is, of course, the compute service from AWS. It has all automation there. We don't care about the underlying servers. We don't care about the underlying systems. We just shipping the code, and everything automatically is spin up for us and should run, right? But what is the most important in my opinion about the Lambdas, by the way, they have right now quite nice way of observe what your Lambda is doing, right? It's not just only CloudWatch, because with CloudWatch, you really do not see things, what's going on inside your code in Lambda. If you put a lot of printing stuff, you can print messages to CloudWatch logs, but it's not too much, I would say. It's not the way how you should do that. So that's why X-Ray and Lambda Insights are very, very powerful here and very, very helpful. By the way, I'm still trying to do lab about observability of Lambdas. So using X-Ray is really what I recommend to you. If you didn't try it before, try it, because you start to understand what your Lambda is doing, really. And this is needed for not only one very specific issues, but the issue which can cost you a lot. This is cold start, right? So what is cold start and how we can measure it? So right now with Lambda Insights and also X-Ray, we can observe and measure very exactly what is this cold start time in our execution. So what is quite important, because imagine the situation. Well, I'm sure that you know a Cloud Guru platform. They built everything on Lambdas. And if you look carefully on the performance of the page, you can see sometimes this kind of This is this element of exactly this cold start. So we can use Lambda Insight to see how many invocation of our lambdas are suffering from this cold start, and X-ray to see the impact of our lambda. And right now it's a little better, especially better if you think about let's say big languages like .NET, Java, etc. It is better with .NET or from the version 3.1. .NET improved the performance, and this cold start is definitely smaller, but Java is still suffering a lot. Imagine the situation that you have a website and your Lambda needs 6 seconds to be, warm up, to start working. So it's not something what we want to see on modern browsers, right? So it could look something like this. So the cold start itself could take like 80% of the execution time of your Lambda function. This is quite unbelievable and quite unacceptable, really, at least in my opinion. With languages like Python, Node.js, Golang, it's definitely better. It is visible. If we will have this possibility, we will even see this on my very small and stupid Lambda function written in Python. But it is quite acceptable. It's like a couple hundreds milliseconds, maybe 200, something like that. So we can live with that somehow. So this is needed. This cold start is happening when your resources, underlying resources, are spin up for the first time. You execute your Lambda. AWS need to create all resources underlying below this level and execute your code there. When it is created for the first time, there is some, let's say, time where your Lambda is warm, and when you execute this Lambda function again, there is no cold start because everything is up and running, and you just execute your code there. Of course, right now you can do the setup when you say, okay, keep for me 10 lambdas warm all the time. But first of all, what happens if there will be 11 requests? The 11th lambda will do this stuff with cold start, etc., etc. And honestly speaking, in my opinion, if you need to keep your lambdas warm all the time, it's not serverless anymore. So it can bring you some headache how to solve the situation here. I had this because we have a website with .NET, and we fought a lot of hours to make it work like a proper browsers. We will use AWS SAM model, right? So this is serverless application model. Generally speaking, what it is open source framework from AWS for serverless, right? It's in fact extension for CloudFormation. So even if you're using only Terraform because I hate CloudFormation and you're using SAM model, you are using CloudFormation. It's optimized for serverless. It is it organizes all resources, or maybe not all, many resources which you need in order to execute a Lambda function. For example, API gateway, for example, DynamoDB. You can create it together with Lambda function in the template of SAM model, and it allows you to locally debug code of Lambda function in the proper way. So you don't need to do some magic, throw away the handler because you need to test your function, and you cannot do it differently because how to run something what is executed in AWS as a serverless, right? So right now, using Docker, you can test your Lambda functions locally, which is very nice tool, and your developers don't have an excuse anymore, so they can test it locally. I said CloudFormation, right? So CloudFormation is the infrastructure as code element of AWS, and infrastructure as code is the automated way to propagate errors in misconfigurations to all environments simultaneously and quickly, right? Somehow I don't like this definition, so let's say that infrastructure as code is an automated way to create, update, and manage infrastructure on all environments as quickly as possible. But it's not only about the speed, right? It's about reliability, it's about versioning, it's about collaboration, it's about having repeatability of your infrastructure, etc., etc. Generally speaking, you are taking your bare metal and writing it into template, YAML or JSON, whatever. But I think it's important to think also about infrastructure as code as a potential threat for your organization, because in 2020. If I remember correctly, 23% of breaches were done because of misconfiguration of infrastructure as code. So it is quite huge number, right? We will use ChangeSets here. And I strongly recommend, if you didn't try it before, try to do it, because this is in my opinion, the best way of executing CloudFormation. And this is the biggest advantage over the Terraform, really, in my opinion. So to do ChangeSet, we are doing two operations. We are creating ChangeSet, obviously. And this is like a changelog, which shows you differences between what you have and what you want to have. And you can use it as a great tool for approval step, because easily you can see what CloudFormation will change in your stack. And also this can be used also for versioning or for changelog in version control or release notes, whatever. So this is a really cool tool to have it. In Terraform, we can say that Terraform plan is very similar, but ChangeSet is operating on real stuff. Terraform plan is operating on templates and stored template and I mean state. So here can be a little bit surprising when you are doing Terraform apply. And execute. After you create the ChangeSet, you can execute the ChangeSet, and this applies your changes to the existing stack, of course. And in case of errors, all changes are reverted. So it's like a classical way of update CloudFormation, but split it into two steps, really, right? And the steps are separated because you need to take two actions, not only one. On the end,
Hey, Pavel.
Sure.
Yeah, so I hadn't heard the statistic before about all those breaches that are due to sort of infrastructure as code. Are you saying that the use of ChangeSets would mitigate those kinds of issues, or are you saying that that's still just a risk of infrastructure as code?
So ChangeSets in this case will help you just to have better governance for your work, for your changes in infrastructure, in code, for trying at least to solve potential threats. We should use other tools which we have. I don't know the name of the tool from AWS right now, but you can test your CloudFormation templates right now with AWS native tools. And also you have third-party free tools like Chekhov, like even Taskat can help you here, because Taskat will create you the whole environment. You can do some test on this like a fake environment and then close this environment after the test. So at least it will show you what can you expect, right? Because even if you do the changes, the malicious changes on environments like QA, etc., well, really no harm will be done if something will happen, right? But because there is no real data, there is no real users, there is nothing real. This is just QA. Hopefully, because I saw the situation where QA had the production data, but your reputation will be harmed. Because if your QA is broken, people can start thinking that your production maybe is not that reliable, like you say, right? So it's better to avoid this situation. Unfortunately, I know more tools for the testing of Terraform than CloudFormation right now, but there are multiple tools which can check your templates not only for the quality of the code, but also about the security of the code. Honestly speaking, they are not fully reliable. Of course, you need to have a common sense and your expertise on the top of it, because many threats cannot be revealed by those tools, or those tools can show you like a not very important elements. Like, for example, Chekhov will show you that your security group doesn't have description, and they treat it as a threat, right? And if you have this in pipeline and you have the test, and your test will be green only if 100% of your template is okay, this will, break your template because you don't have the description of the security group. Well, I leave this to your judge if this is smart or not. So in this case, we need to use separate tools, I think, for this. And right now, even we have security pipelines or tooling like for example, Aqua, for example, Bridge Crew doing this as well. For example, Accurix doing the tools which are assessing your templates and assessing your actual infrastructure, and they can create even pull requests to your code in order to fix issues. So you can automate this response on threats process very, very, very well. Unfortunately, those tools are expensive, but maybe in time they will be cheaper. So ChangeSets are definitely more for like a governance stuff, keeping the sanity of your changes of your version control than security checks.
Yeah. So if I could just sum that up. So the context, the way you're juxtaposing this was that there's some risk in using CloudFormation or infrastructure as code, I should say. And ChangeSets is the beginning of some governance that can help that, but it's only one small piece of a pretty broad puzzle of pulling together the best tools that are available, but they may not be enough. And we still there's still a role for security researchers. There's still a role for code reviewing to comprehensively look, because we're not there that we can be sort of fully automated in detecting all possible threats, which of course. So
yes, exactly. So this can be like a good start, but not a lone tool for achieving this. Yes, exactly.
Okay, excellent. Thanks.
Yeah, great. So on the end, we have CodePipeline, right? So CodePipeline is AWS approach to CI/CD, and we have multiple components here. So it's like a complex tool, really, starting with code commit, where this is like a version control for your code, right? So we have code artifact, when you can store code. Finally, we have it from like 1 year or something like this. So we don't need to use S3 anymore for this, at least for .NET, Java, Python, Node.js. So it's a great solution. We have code build, which we're using for building artifacts, testing them, and do everything except deployment, right? Because for deployment we have code deploy. But I think in many cases, many teams are using code build to deploy stuff because it's easier, it's faster. Code deploy is quite complicated if you are looking on it for the first time, because it needs special IAM access. Sometimes when we are talking about separate accounts or environments, we need to have a code deploy on both of them in order to work properly. In case of code build, we have only one, and we just assume role from another account and deploy there, easy like this. But code deploy is the design tool for deployments. And also it can help you to achieve blue-green, canary deployments, etc., 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 etc. We have obviously CodePipeline, which is like a wrapper on everything, and then very nice thing, which is from also quite recent in AWS is Code Guru, which allows you to assess your code, assess your changes, quality of the code using machine learning. So the more code is checked by Cloud Guru, the better judgment Cloud Guru can give you, right? So it's like a helpful tool together with like a SonarQube or things like this, right? So you can assess your code from different angles. So do you remember what we will deploy? Probably yes, so good. Very simple thing, API gateway, Lambda function. And for this, we will complicate things as much as we can to have reasonable solution. So we will use AWS Lambda, right? One single Lambda, because this is like a demonstration. We will use, of course, API gateway. We will use SAM model CloudFormation template to deploy Lambda and this API gateway, and CloudFormation to deploy code pipeline itself. We will use also ChangeSets. We will use a second, something happened here. All right. We will use event bridge. This is something what we need to connect code commit with our code build. There is, in the case like I have, there is no direct connection. So my commits to code commit doesn't trigger automatically code build. I need something what will trigger them. So for this, I have event bridge. So every commit to master creates event, which is observed by CodePipeline, and CodePipeline based on this event execute the pipeline, right? We will use code commit, as I said. We will use code build in multiply by 2, if I remember correctly. We will use code deploy. We'll use, of course, simple notification service to send the notification to the user, because we are building the code. We are building a continuous delivery. Of course, we need roles, policies, etc., etc., etc. So IAM, and of course, we need S3 because SAM model is storing code or package in S3. So if you think that's enough of icons, then you are wrong, because there are more of them. But right now, in more organized way, let's say. So this is what we will build, really. So we're starting with code pipeline here, right? And this code pipeline is contains a few elements. So we have code commit, which already exists. We have code build for testing. We have code build for building the artifact. And on the end, we will do deployment using code deploy. And by SAM template, we will deploy API gateway and Lambda. Here for code deploy, we will use also notification for manual approval. And in order to have this connection here, we have event or event to in order to trigger our build. And code deploy itself contains also 3 elements. So we will create the change set. After the change set is created, the email will be sent. And after approval, we will execute the change set, and the change will be done into in the code of Lambda function, right? Right, so enough talking, I think. We can go to the console. So let me show you first but first I need to find my browser. Give me a second, I need to log in. I don't know many people. Honestly speaking, I don't know anyone who has a federation and organization at home, but I have. So I need a few minutes, few seconds to log in to one of my accounts. All right. It should work. Yep. So in order to show you that I don't have stuff created at this moment. So let's go to CodePipeline first. Okay, there is no CodePipeline, nothing is there. And if I go to CloudFormation, it's also empty. All right, so what we will do, we will create a stack. And I will show you the stack in my Visual Studio Code at this moment. But first, we will deploy this function. Very, very simple function, very static. It's doing for mathematic operation as a functions, just for having some test cases, which we will use to generate report. So nothing complicated, very, very simple. We will use this SAM template in order to deploy our Lambda function. And here we are saying that this is CloudFormation transform. So what AWS will do during the deployment of this template, it will transform or translate this small template into proper CloudFormation template. Right? So all resources will be reshaped into proper CloudFormation commands, statements, etc., in order to create API gateway, in order to create Lambda function, IAM roles for the Lambda function, etc., Because please observe that there is no information that I'm creating, for example, any IAM role here. For simple cases, it's not needed. Of course, if you have proper application, you should have properly defined IAM roles and policies, etc. Here, we don't need it. So what is happening here? So we are saying that for our function, we will have handler. So this place which a Lambda function executes where is invoked, called handler, very, very creative from me. The code of the Lambda function is stored in Lambda function directory here. This is what I showed you before. This will be taken into and packed and sent into S3 in order to be deployed. I'm using Python 3.8 and I'm setting memory size and timeout for me. I also enabled tracking for X-ray here, just because I can for this demonstration. Here you can see that I'm creating something additional to this Lambda function. It is API. This API will be called simple API, very creative again, and it will contain only one endpoint with only one method, and this function will be assigned to the specific endpoint. Simple like that. Right? To make things a little bit more complicated, we are going to code of CloudFormation. It's high, almost like a rack in the server room. So first, I have a few parameters which I need to have. This email is to send me the notification that pipeline is waiting for my approval. As I told you, I have my repo already created. So I need to connect my pipeline somehow to this. That's why I'm passing the parameter where my repo is stored, or what is the name of my repository. I'm creating a S3 bucket in order to store artifacts for my Lambda. Topic for notification, bunch of roles. So I need roles for CloudFormation. I need roles for CodePipeline itself. I need roles for code deploy in order to be able to take the code and deploy this code. And this is the most, I believe, tricky part of code deployed for many people to create proper role for the specific use case. So there is a lot of roles and a lot of policies. And here we start with our Lambda pipeline. So we are creating pipeline and we create here stages. We have first stage, with which we need to start. This is the stage where we are pulling the code from repository. No matter if this is code commit, GitHub, etc., we need to pull the code from repository, and this is the first stage of our pipeline. Well, I said no matter. No, I lied. If you have, for example, GitLab or Bitbucket installed on-prem, or it's not enterprise, it's not cloud version, you need to do some additional wiring using Lambda functions, storing this code somewhere. It's hell. Don't do that because it's quite manageable if you have only one pipeline, only one repository. When it starts to grow, it starts to be so complicated that you, in some moment, you're starting to to lose control on it. So this is one of constraints which I said on the beginning. If you have the tool to which connection is not that straightforward, maybe you should think about different tools. Right? Because why complicate simple things? So we are pulling the code. After that, we have another second stage, which is test and coverage. Here, I'm defining the stage only. I'm not saying what is going inside. This is my relation to what will be inside. So we will go there in half a minute. Third stage is for building artifact, and fourth stage is deploy Lambda. It's called deploy because here you see this category is called code build, code deploy here, and we have like 3 actions: create ChangeSet, manual approval, and execute ChangeSet. By the way, this code is available. There will be a link in the next slide in like 20 minutes or so. So you will be able to play with this by your own.
Pavel?
Mm-hmm.
So we could get your code, that's helpful. When you started to create this, did you start from some template that you got from AWS somewhere, or did you just go to the doc and start typing lines?
Documentation, mainly like 80% documentation, stage by stage, because honestly speaking, this was my one of the first attempt to do pipeline as code. So not clicking through the console, because this is easy and we don't like easy things, right? So mainly I based mainly on documentation. Of course, I watched some examples to have some impressions, maybe better approaches based on what I'm doing and what others do. But it was written completely by myself and with help of documentation, because without this, I'm like a blind man.
Right. It's always good to know where these things start from, because sometimes there's some resources where there's good boilerplates, and other times where you just got to find the right blog to start, where you write it yourself, and then you keep copying and changing it, and remember where you kept the last good version. Okay, thanks.
So generally, I based on documentation where a few snippets are available. So based on this, I started to reshape it into my needs.
That's a lot of documentation. Were you on a vacation or something to go through a lot? I can see that's like over like 3,000 or 4,000 lines of CloudFormation, right?
Maybe not 4,000, but like 400.
Sorry, my mistake.
Still
about 500. Yeah.
Still a few. Let's say. Well, I'm working in normal hours, but as you can see, it's here it's 1 a.m. and I'm still really alive. So I am night owl, and it's completely okay for me to sit late and play with this stuff, because why not? I like it. I love it. Really. So I'm spending my time on playing on this. Yeah, so we have manual approval, and here we are sending the notification to this notification topic, to which I am subscribed with my email. Very straightforward notification information. There is a possibility even to add, what this change set into this email, but I didn't do that in this simple example. And after this approval is done, I'm executing the change set, and that's it, right? Here we have the description of the steps, so detailed description what we are doing. So we have like a build artifact, and we have configuration, and this configuration we are saying what is inside this step in this stage. So for Lambda test, I'm saying that few things which I need to say, but I'm also selecting the environment on which I will build my stuff, and then it's simple, very common way of describing the steps one by one. So I'm saying that I want to have Python 3.8. I installing PyTest and PyTest coverage in order to do some tests and coverage, and executing this. And on the end, the most important here is creating the report. And this is cool functionality, also not that old in AWS, because in the beginning we didn't have this reporting. So as you can see, I'm creating here two reports. One is called Lambda Test Unit, where I'm sending the all files from the reports directory. And second is Lambda Test Coverage, where I'm sending all files from the coverage directory. So I split those two functionalities into two different reports on which I can fail my pipeline, and it will be very easy and quick for developers to understand on which element, like a high-level element, the pipeline was failed. It's definitely easier for them, and this is my lesson learned from work with developers on Lambda functions mainly. So this is the one thing, and the second build is really this is the most important element here. I'm doing CloudFormation package, so I'm packaging this SAM template into zip file and sending to S3 bucket in order to be able to deploy it. So besides the all lines here, this is the most important line. And I'm saying that I'm sending zip with those two files, really, in order to deploy my function. This is my event. I told you before that I need to connect my code commit with CodePipeline, or first code build, this one, or let's say code pool. This is this definition here. And very simple, I'm saying that my resource is my pipeline, my repository, and if anything change here for the branch master, the event should be published. And on the end, I'm creating the reviewer of CodeGuru. CodeGuru gives you two options. You can have code review, and you also have I don't remember this moment, but in this case, code review can be used. It is very functional. When you have pull request, code review will assess your code as an additional reviewer and give you hints, advices, what to change in your code. One information though, I'm not sure if there is right now the possibility to have code reviewer as a element which can fail your pipeline, because even if I have code reviewer enabled, I am able to merge even if code reviewer is still working. So this is something what probably AWS should improve, or they are working on it maybe, because this will be very helpful. Code review takes some time, but still less than like a human-based code review, and should be like a element which cannot be overruled, let's say, or at least there should be a possibility to do this as this way, right? So this is the whole CloudFormation, right? So right now I will try to deploy it. Let's see what happened. Okay, so obviously we have our beloved AWS CLI. So this command I will show you on CLI to prove you that I know CLI. So of course we are using CloudFormation here. As I have multiple accounts, I'm using my profile here to pass proper credentials. I called my demo. What I will do, I will create a stack. I will call this stack, well, let's be creative, demo. All right, let's be creative, Lambda pipeline. All right. Right now I need to pass information where my template body is. I have it on my local computer, so I need to pass this parameter, template body. And this template body is in the file in my directory IAC, and it is called CodePipeline YAML. Right. Right. As I'm creating a few IAM resources like role, like policies, I need to inform CloudFormation that I am aware of that. That's why I need to pass this option, capabilities. And in this case, it is capability. Right.
Was that meant to be template body BODY or BODE? Like
Typo.
Of course, yes. Thank
Yeah.
you. See, I can be alive at 1 a.m., but I'm not. I'm a little bit. So this is it. And do you remember I had a few parameters in my CloudFormation template, right? So right now I can provide these parameters. And one of them was notification email, and I will use my my real one. Value is so you already know where to write to me. And also I have the second one, which is the name of my repository. So let's pass it as well. It was repository name, and parameter value is CI/CD Lambda. This is what I remember. Yeah, let's try to execute it. Okay, something is wrong. Of course, I know even what. All right.
you got a single quote instead of a double.
Yeah. So let's try to paste it. Of course. Wow. Okay, so let's see. Something should happen here. Our Lambda pipeline started to be created. We can go inside our CloudFormation and see our events. It will take some time, but what is beautiful about this? When you create this pipeline, it's already start to execute this pipeline for the first time. So quite nice, I think, because we are going into GitOps direction here as well, right? So we are compacting every element here, code, infrastructure, pipelines together, and make it more automated. All right, so it started to create things, right? I should receive an email where I need to confirm my subscription, and this is quite correct. So I have my email here that my notification topic was created, and I can subscribe to it. I'm doing this on the second window, so that's why you didn't see it, the subscription itself, but it's quite simple. You just click and done. Right. Right now, this event is created, which connects to the repository with the pipeline.
So roughly how long does this typically take? And I guess the question is, should we do our raffle while we wait for the stack to get created, or
I think
is it almost done?
it should take like a minute or two max. It's quite fast, 2 or 3 maybe. So it should be quite fast. We can go to the CodePipeline and see what's going on there.
Because if you want, I can do the raffle now while we're waiting, or you could just talk through
Yes.
however you wanted to do it.
We can do it now, right? Yeah, that's no problem for me. So let's just final check. Oh, you see it's complete. So sorry.
That's good.
So as you can see, stack was completed, right? And automatically my pipeline is executed. So let's see what is inside. We have get source. We have coverage as a second stage. We have building the artifact, which is in progress right now. And on the end, we will create the change set, approve this change set, and execute the change set. But let's go one by one to the interesting part. So test and coverage. As a code build, this is like entity called code build. You see it here. You have every single element printed here. So just like in every single other tool for CI/CD, right? But what is nice, really, you can see the tests we done, and as you can see, these 2 reports are created. For my case, I'm using the same name like previously, so there will be more than one execution printed, but this is not a big deal. Come on. So this is the report. You can see how many tests were executed, how many passed, how many failed. So I'm that great developer that I don't have failed tests. Here you have the information about them. With even if you I don't have any messages, but you can have even messages from every single test, right? So this is the test itself, and even more, if you go here, you can see the group and see the past trend, or the trend, past execution and the trend of your executions, which can be very helpful, right? And this can help you to create metrics for your CI/CD, and you can see easily that, for example, something happened and your execution for the specific stage become longer and longer and longer. So this is the moment where you need to look at it, because maybe there are more tests. So all right, but maybe something happened, right? So this is one thing. And the second thing is my coverage. As you can see, I have 87.5% of my code covered by tests. So as a person who is not a developer, it's quite good, I could say. And again, the same thing here. You can see the past executions. In this case, it's very boring because it's always the same. So this is the build itself. In case of build artifact, there is nothing special. Only one thing which can be interesting is, because there is no reports, nothing like that, it's just simple log. But interesting is that one thing here is different than in other builds. When you go to phase details, you will have this upload artifact, right? So it also can indicate some issues maybe with your infrastructure, with your configuration, with your network, for example, if this time start to be longer and longer and longer. This also can be indicator for you that something is happening in your pipeline.
Hey, Pavel. Can I just do a time check? This is really interesting, and I'd love to see more of it. But it's getting late. Well, certainly late for you, and we're starting to lose people just on the count of people that are joining. So I just want to just calibrate.
Sure.
How much more do you think you have?
5 minutes max,
Okay.
maybe less.
Okay,
maybe
so
less.
let's do that so people know if they can stay.
Right.
That'd
So
be great.
what we will do, yeah. So what we will do right now, we will see the change set. As you can see, change set is created. So let's see it. If my network allows me. My network went to sleep, and you can see right now the change set here. So this is the things which we are adding. So right now we are running this for the first time. So we are adding all stuff for our Lambda function, right? So all right, I'm okay with this. Of course, this change set is also here. I need to refresh. No, it's not here. Oh, of course, it's not here because this is different stack. Right, this is this one stack. So we have this change set here. It will be exactly the same. So we are okay, we can approve this. And right now the execution should start in a second or two. Sometimes CodePipeline need a few seconds for it. But it should start very quickly. And after that, this change set will be executed and will disappear from this list here, as it happened right now. And now this is in progress. So we should have already Lambda function created. Yep, so we have Lambda. This Lambda is here, is created. We can even test it with a very simple test event. Nothing here is needed. Oh, right, save. We can test it right now. Yes, you can see it works. It will give me the answer. It's this 4 mathematical operation were done. And also what we will not see right now, because this is a few minutes is needed, we can even see the insights, we can see the traces, and we can see chain advices from Code Guru if we will update our code, right? So to not take more of a time, I think that's all for the presentation. So yeah, this is the location of the code if you like to play with it. And generally speaking, I finished. So last slide is stay in touch. Done.
All
Enough.
right. Well, that is awesome. And if you could maybe post those links to the chat, would be if not, people can take a picture of the
Yeah,
screen.
sure, of course. So let me just stop sharing
Can you,
I will.
Could you just show the QR code for the code where the code is?
You know what? I will do a print screen and copy this print screen to you. Okay? Will this work for you?
That's perfect. Perfect. Thank you.
All right. So I will first. What I need to do is to find how to stop sharing. That's interesting. You share? No, that's it's interesting because I'm still sharing, right?
Yes. Yeah.
Pause share. Oh yeah, that's the stop share. Oh yeah.
There you go.
That was complicated. Okay, so I'm doing the print screen right now.
So that was awesome, and I think
Thank you.
you know, one of the things to take away from this is, right, there's a lot of lines of code there, there's a lot of steps, but more or less that's a one-time setup to build the pipeline, get it going, and then after that you just commit to deliver, commit, deliver, and then click deploy. So I don't want to get lost, right? The kind of the beauty of this is that it's a bit of setup, but of course, if we copy your link and can have an example pipeline to create, but then when you have the pipeline, and that's a one-time thing with some changes over time, of course. But then you can, obviously commit your code and have it automatically go through the delivery process. But then also, it's pretty minor to make changes to an individual step, right? Because those are just calling out to other artifacts. So you can change, what's going on in build step 1 or build step 2 or whatever. So again, once the whole skeleton of the pipeline's there, those individual pieces can be changed and updated, fairly easily. So it's a worthwhile investment.
That's
so
true. That's true. And you are doing this once, right? And then you are using it. What is also beauty here that with SAM templates, you can pack your logical functions, right? The functions which are doing this similar thing. For example, I don't know, update and reset the counter, right? They can be deployed in the same template. So you don't need to create another pipeline just for this specific use case. So you have like a complexity and scalability here, and even I don't even have the word how to name it, but you can shape your repositories, your pipelines, your strategy together with the logical business needs, so the business separation here, right? And also, this is very simple example, right? But here you can also add things like canary deployments, like blue-green deployments, like rolling deployments, etc., etc., etc. This needs, of course, a lot more work, because you need something what will control your deployments in order if we can continue or we should come back. But again, you are doing this once and just then scale, right? So this is the beauty of infrastructure as code at all, right? Because
So great. It's very late for you. We're getting late for this crowd here. But let me quickly, since I promised, share my fancy number generator here.
You need Lambda function for it.
I know.
If I knew, I will write something.
Okay, so we are raffling off the exciting $50 AWS credit, and I'll basically spin a number and then look at my screen here to see the number that you show up in the list. So are we ready? All right, number 9. Now I got to count 1, 2, 3, 4, 5. 6, 7, 8, 9. Peter College, are you still on the line? Peter, you there?
I think it's
Peter.
not there anymore.
Yeah, Peter fell asleep in his soup for over dinner. So I'm going to respin the number generator.
So I did a good job here.
Yeah, I'm here. 10, that would be Zin. Zin, are you here?
I'm here.
They're all in chat.
Yeah, excellent. So if you want to Slack me your email, and then I can send you the AWS gift code. Yeah, and if well, probably best to join me on Slack. If not, you can mail ken@cloudpegboard.com. And I have, let me go back. I have one more, so I'll spin again. See how many people we got left here. Okay. Number 5, 1, 2, 3, 4, 5. So Drew, is that actually your name, or is that?
Yeah, that's my name actually.
Okay, I wasn't sure if that was partially initialized. So congratulations, you won another $50 AWS gift.
Yeah, this
credit.
is my email address.
So if you could Slack me, and again,
I'll send you.
This is Ken, not Brian, or ken@cloudpegboard.com. And let me stop sharing here and find what screen that's on. All right, so Pavel, again, this was really interesting. I
Thank you.
really enjoyed this talk, so thank you so much. And it is late, so normally I would just kind of shut us off, but I kind of don't want to stop. If there's anyone have any questions or just want to take them offline?
It's almost the middle of the day for me, so birds here will just wake up. I will go to sleep. So everything is preserved in the nature. So.
All right. So anyway, got some good comments. People enjoyed it as well. So, all right. Well, we'll do that as a wrap. This has been recorded, and I will post that next, probably sometime over the weekend, onto our YouTube channel. So everyone who's stayed up late with us through your dinner or whatever, thanks for joining. We have another talk in 2 weeks as usual. We're trying to keep that pace. And let me just quickly see my note, because it just changed like an hour ago. The topic, it's Cognito to manage customer identity in IAM for mobile apps. So keep a lookout on the meetup group, and thanks everyone. Have a fantastic night. And thanks again, Paweł. This was really interesting.
Thank you for having me. I was very, very happy to be with you and share my knowledge.
Excellent. Well, I hope you can come back another time.
Yep.
Yeah, absolutely.
I have a few more.
Can I send you a message on Slack? Did you get it? Can you just check?
I will check before we lose you. I am drowning in Windows. Yes, I have it. Thank you.
All right, perfect. Thank you. Thank you, Ken, and thank you, Pawel, for
Thank you.
kind of late for you, right? Unless he's hung. Oh no, sorry, you're here.
John, Timothy, everyone else that I can see.
Thank you, everybody.
Thanks everyone. Have a great
And
night.
thanks, Ken, for arranging
Thank
this.
you very much. And
Thanks.
have a good time. Bye bye.
Bye bye.